In exactly 48 hours, an extraordinary event that NASA has been quietly preparing for will take place. An object from another star system moving at 137,000 miles per hour will pass Mars at a distance of 29,000 kilometers. But this is something they don't tell you. Professor Avi Loeb of Harvard says he rates this object at 6 out of 10 on his scale of potential alien technology, meaning 60% believe it is not natural. And when you see what amateur astronomers have just captured, you will understand why. The scientific community is in absolute chaos because this object does not behave like any comet we have ever seen. It is releasing pure nickel without any iron, which is impossible in nature. This only happens in industrial production. Its chemical composition is 16 times more extreme than any known comet. It changed color from red to blue in just one night, and its orbit has a probability of being random. Only 1 in 500, but this is when things get scary. At the end of September, the Atlas disappeared behind the Sun for 2 months. We will not be able to see it during its closest approach on 3010. Loeb suggests this may be a deliberate action to avoid observation when it is brightest or when something else is happening. Some scientists believe it may have deployed invisible, tiny scout probes too small for Earth telescopes to detect, and they could approach Mars while we are all watching the main object. More than 227 observatories worldwide have tracked this object, compiling over 4,000 observations. And each data point makes it even stranger. With a mass of 33 billion tons, it should not exist. Calculations do not yield reasonable results. Logically, we should have found 100,000 smaller objects before discovering something this huge. So, what on earth is by Atlas? In the next hour, I will show you all the anomalies, all the leaked observations, and every theory that scientists don't want to discuss publicly because after 310, when spacecraft on Mars point their cameras at this object, we may finally have the answer. Or we might receive something far more worrying. If you are as fascinated by this as I am, please hit like and subscribe and let me know in the comments where you are listening from and what time it is there. And what is the strangest thing that has ever happened to you? Chapter 1. The shocking 6 out of 10 rating from Lab Avila. Lab has just done something causing waves, shaking the field of astronomy. The Harvard astrophysicist who claimed Oumuamua could be alien technology in 2017 has now rated Bahia Las at 6 out of 10 on his scale of potential technological origin, meaning 60% believe this object is not natural. And before you get skeptical, understand what changed his mind. It was not speculation. It was data from the James Webb Space Telescope, the Very Large Telescope in Chile, and Hubble, all showing things that should not exist. Webb observed Atlas on 6/8 and found its gas cloud contains 95% carbon dioxide and only 5% water. This composition is 16 times more extreme than any known comet at that distance from the Sun. Comets are supposed to be water-rich, but this one is not. Then, the Very Large Telescope detected nickel in the gas cloud with strong, clear emission lines. But here's the key point. There is no iron at all. In the entire history of observing space objects, nickel and iron always appear together. They are created together in dying stars and expelled together in supernova explosions. Finding nickel without iron is like finding smoke without fire. It does not happen in nature. But it happens frequently in industrial production. High-purity nickel alloys for aerospace parts. This signature matches factory production, not space debris, and the nickel output is increasing. When first detected in July, the emission rate was modest, but by August it had exploded 25 times. The closer to the Sun it gets, the more metal it vaporizes. Lab has faced harsh criticism for daring only to propose extraterrestrial explanations. Jason Rye of Penn State University called his work NASA's Tom Stellar Bridge, saying it looks like a comet and behaves like a comet, but both. Neither can explain the presence of nickel without iron, nor do they mention the extreme CO2 ratios or the probability of the orbit is random, only 1 in 500. Even the Webb calculations admit their technological hypothesis is mostly a thought experiment. He said the most plausible result is still a natural comet, but plausible does not mean certain, and with a rating of 6 out of 10. He is saying there is a 40% chance we are wrong about everything. The flyby of Mars on 310 will tell us more. If the high-rise camera shows a nucleus larger than 5 kilometers as his mass calculations suggest, then the natural explanation will collapse. There is not enough rocky material in interplanetary space to create such large objects at this frequency. About 2 amateur photos have caused an internet storm. Social networks are exploding with something professional astronomers would not touch. Amateur astrophotographers are sharing images of ILS that do not look like a comet, instead of the diffuse, hazy glow you would expect. Some photos show geometric structures with sharp edges that should not be there. Michael Jackson and Zero Ramon, 2 highly respected amateur astronomers, captured ILS during the total lunar eclipse on 7/9 from Namibia. The images show an object emitting blue light 6 with blue 5 light. Clearly gaseous and visible in both blue and blue 6 filters, professional astronomers have admitted these images are valid, but it is other amateurs, whose names have never appeared in press releases, who took what are now called structured images. The images circulating on Reddit, Twitter, and astronomy forums show something solid, firmer, clearer beneath the gas shell, something that looks less like a diffuse cloud and more like an object with edges. The professional reaction is either silence or immediate dismissal. When questioned, they cite motion blur, tracking errors, exposure faults, telescope tracking issues. All are valid technical concerns when photographing fast-moving objects, thousands of times dimmer than the naked eye can see. Blur and distortion are common problems, but this is what makes this interesting. The Atlas Survey Telescope discovered BAY. Atlas is only 20 inches in diameter. That is the size of a backyard telescope. Enthusiasts own equivalent or better equipment. At SAO, when someone with similar equipment captures unusual structure, it is automatically dismissed without investigation. On Reddit's astronomy subreddits, debates are fierce. Users compare images side by side. Some show classic comet shapes with developing comet heads and faint tails. Other images show something harder to explain: solid cores, unusual shapes, pixel patterns that do not match the standard pixel spread function for stars or comets. Half the commenters shout that it is image processing error. The other half demand professionals reproduce observations to confirm or refute it. That has not happened. Instead, professional astronomers jump into discussions to discredit without offering to check the images themselves. An image widely circulated on X shows a core that seems firmer, less diffuse than the image taken by Herbo. This amateur claims it was taken with a 14-inch Smith-Cassegrain telescope and stacked from 50 individual exposures. This is a standard procedure for deep space imaging. Professional astronomers immediately cite atmospheric distortion, tracking drift, chromatic aberration, anything to explain it away, but none of them suggest pointing larger telescopes at the same coordinates. No one offers to help verify the observation, only dismissal. This is what makes the situation strange. Images from the Hubble Space Telescope on 21/7 show a teardrop-shaped dust cocoon, with a glow extending forward, the object facing the sun. That is official NASA data. And it violated comet tail predictions, which are supposed to point backwards, pushed by solar wind and radiation pressure. This one points forward. Professional astronomers call it interesting, puzzling, worthy of study. When amateurs see strange things at the same time, it is called user error. Then the Gemini South Telescope captured images on 27/8 showing the first evidence of a true anti-solar tail pointing away from the object, so something changed between July and August. Either BAI Atlas began to behave more like a traditional comet, or our viewing angle changed enough to reveal what was always there. Most amateur photos showing unusual structure were taken during the period. From July to August, when this object behaved least like a comet, even professional observations also showed anomalies. And this is another data point that did not get enough attention. NASA's Spitzer Space Telescope observed BAI Atlas in early August and saw it as a point source. No extended comet head, no tail, just a tiny dot. That is not the shape of a comet. In the infrared spectrum, they show extended emission from warming gas and dust, but Spitzer saw nothing like that. Just a single bright point. So, we have a rule: professionals see anomalies. They cannot fully explain, amateurs see anomalies dismissed as incompetence. Both photographed the same object at the same strange time when it did not behave like a comet. The Mars Express, an ExoMars trace gas orbiter of the European Space Agency, will photograph BAI Atlas on 310, with cameras designed to image the surface of Mars from just a few hundred kilometers away. They will photograph this object from 30,000 kilometers. As stated, they do not expect spectacular images. It will be smaller than a pixel in their cameras, but if amateurs have seen something real, then, if the comet has structure beneath the gas layer, the October observations may also not solve the problem. We may need something closer, something with better instruments aimed directly at this object. Without atmospheric disturbance, the truth is we are flying almost blind. Professional telescopes have limited time, and specific observation schedules. Amateurs have flexibility but less sophisticated equipment. And somewhere in that gap, something unusual is happening that neither side wants to fully admit. Because if amateurs are right, if there is structure that does not match natural comet morphology, then we are no longer talking about image error. We are talking about rewriting what we think we know about interstellar visitors. BA Chapter, The Mars Encounter, 310, What They Don't Tell You in 2 Days. BA. Elias will pass within 29,000 kilometers of Mars. Sounds like a safe distance. But here is something no one discusses: the minimum orbit intersection distance, meaning the closest point. That this object approaches the entire orbit of Mars around the Sun is only 2.7 million Coriolis. Webb calls this a significant tweak. When a physicist at Havas uses those specific words, you need to pay attention. The high-rise camera on the Mars Reconnaissance Orbiter will image BAI Atlas at 30 km per pixel on 310. That resolution is detailed enough to separate the nucleus from the surrounding dust cloud, detailed enough to measure the actual surface area reflecting sunlight, and detailed enough to confirm whether this object is really 5 kilometers wide, as the latest mass calculations from Webb suggest. Or not. If it is that large, the natural comet explanation will completely collapse now. Material sources are limited in interstellar space. We should have detected about 100,000 smaller interstellar objects in the Oumuamua size range before finding something huge like BAI Atlas, but we have only found 2 previous visitors, both tiny compared to this object. But this is when things get really worrying. Webb has calculated that if BAI Atlas deploys a pre-encounter probe, a smaller scout ship moving ahead of the main object by about 30,000 km, that ship could reach Mars on 310, or the week before. And here's the scariest part: ground telescopes cannot detect objects smaller than about 100 meters at Mars distance. That is almost the size limit of all spacecraft ever launched by humanity. Any pre-encounter probe would be completely invisible to us. This idea is not as crazy as it looks if you are designing an inter-asteroid mission to survey a planetary system. You would not send a single giant ship. You would send a mothership with smaller reconnaissance probes deploying ahead to collect data on each planet while the main ship follows a safe orbit through the system. That is exactly how we would design such a mission if we had the technology in the orbit of BAI Atlas. Making this worryingly reasonable, the object's trajectory only needs a velocity adjustment of 10 to 15 km per second. In September, to reduce its closest approach to Mars to zero for a technological object. That is a negligible maneuver for a natural comet asteroid that is impossible. The ejection speed of ice fragments from comets is increasing based on data from the Webb telescope. Only about 0.4 kilometers per second, not nearly enough Mars Express and NASA's ExoMars Trace Gas Orbiter. We'll also observe Bay Atlas on 310 with various instruments including high-resolution cameras, spectrometers, and particle sensors designed to study the surface and atmosphere of Mars. But they are being repurposed to study this visitor. The instruments will try to describe the activity and volatile composition of the comet from about 30,000 kilometers, but there is a secondary objective that no AI advertises. HiRISE will not only photograph the main Bay Atlas flyby, it will scan the surrounding space looking for anything moving ahead. Of the main object, searching for proposed pre-station probes lab clearly stated this. In their blog posts, using Harris to search for objects preceding Bay Atlas and approaching Mars closer than the main object. If material from Bay Atlas reaches Mars in October, that material could not have come through natural ejection and outgassing. That would be a sign of technology, also a suspicious timing. Bay Atlas reaches its closest approach to Mars exactly 1 week. Before it disappears behind the Sun from Earth's viewpoint, we have a good view from spacecraft. At Mars, and then the object disappears in the Sun's glare for 2 months. It will be unobservable until early December if you want to send something to Mars undetected. This would be the perfect window to deploy your probes on the 310 flyby while Earth telescopes track the main object. Then the mothership hides behind the Sun for 8 weeks while the probes do whatever they came to do. NASA's Curiosity and Perseverance rovers on Mars' surface might also try to observe. Although the comet will be extremely faint from the surface, the Mars orbiters are actually our best chance to get detailed images. Then the question is, what happens if they find something? If Harris captures an image showing multiple objects, or unusual control or anything indicating artificial activity, what would the procedure be? Do they announce immediately? Do they verify with additional observations? Do they classify it as confidential information? No procedure is established for this scenario because no serious AI plans for it doctrines to detect extraterrestrial intelligence. Focus on radio signals or optical beacons, not physical spacecraft passing through the inner solar system. In 24 hours, we will know if amateur astronomers are seeing something real. We will know if the nickel-iron signature means what Webb thinks it does. We will know if the minimum orbit cutoff distance of 2.7 million kilometers is coincidence or design, or we will see a completely normal comet nucleus, consistent with natural formation, and all speculation will collapse in confusion. But either way, 3/10/2025 is a date that could go down in history, the day we either confirm Bay Atlas as a strange but natural inter-asteroid comet, or the day everything changes. Chapter 4. Shocking news about nickel-iron. The Very Large Telescope in Chile has just detected something that should not exist naturally between late July and late August 2025. Spectral observations revealed nickel atoms strongly outgassing from Bay Atlas, with strong emission lines at multiple wavelengths. Clear, unmistakable signs of nickel outgassing from the surface of the object when it approached the Sun, but there was no trace of iron at all. There were no emission lines at any expected wavelength where iron should appear for me to explain. Why is this so shocking? Nickel and iron are the universe's twin pair, created together, in the same nuclear reactions inside giant stars when those stars explode as supernova. Nickel and iron are expelled into space together. They condense into dust particles together. They are incorporated into asteroids and comets together. In every space rock humanity has ever analyzed, whether meteorites fallen to Earth or samples brought back from missions, nickel and iron appear in predictable ratios. Finding one without the other is like finding hydrogen without a proton. It violates the basic chemical principles of how the universe works. A large telescope team of researchers, with no connection to the more controversial claims of Avi Loeb, published their findings with carefully worded conclusions. They suggest nickel may come from nickel-carbonyl compounds, molecules theoretically able to exist in the extremely cold interstellar environment. These compounds are volatile and break down when exposed to ultraviolet light to release nickel and carbon monoxide. But even the large telescope team admit this would be unprecedented, never observed in any comet, in the solar system, never detected in interstellar space, a purely theoretical explanation, for an observation demanding an explanation. This is what makes it worse. Nickel output was unstable when Biolus was first observed at a distance of 3.9 astronomical units from the Sun in July. The nickel emission rate was about 10 to the power of 21 significant but not alarming. By the end of August, at about 2.85 astronomical units, that rate had increased 25 times. 25 times the amount of nickel ejected from the surface in just 1 month. The closer this object gets to the Sun, the more its metal emission increases abruptly. And that increase does not follow the gradual curves we see with outgassing of normal comets. It rises exponentially and steeply, like something is systematically evaporating. Due to increasing temperature, Avi Loeb pointed out something no other AI wanted to say clearly. On Earth, we separate nickel from iron regularly in industrial processes. High-purity nickel is used in specialized alloys for aerospace applications. Electronics, batteries, anything requiring specific thermal or electromagnetic properties, the signature we are detecting from Bay. Atlas matches industrial nickel production, not natural cosmic abundance. Critics immediately jumped on this issue. They say the lab is cherry-picking data, seeing what it wants to see, engaging in motivated reasoning. Jason Ray of Penn State was particularly harsh, calling the comparison to industrial processes misleading and unscientific. But here is what critics do not mention. If nickel comes from natural carbonyl compounds, then where is the iron forms similar volatile compounds? Iron pentacarbonyl is well studied in chemistry. If conditions exist to create and preserve nickel carbonyl over billions of years in interstellar space, those same conditions would also produce iron carbonyl. Both should be present. But only nickel appears. Observations from the large telescope also detected a rapid increase in production of cyanide, hydrogen cyanide, and related compounds in the gas cloud around Ba. Atlas, with a sharp increase as the object approaches the Sun. The lab suggests the color change from red to blue, SIC, observed by amateur astronomers may be related to the sudden spike in cyanide. Cyanide itself is not unusual in comets. It is a carbon and nitrogen compound, commonly found in many icy bodies. But the steep production curve increase matches the nickel emission, indicating these processes are related in some way. What is really fascinating is what this tells us about the composition of the object, if most of the mass is in the form of carbon dioxide ice with a small amount of water, as Webb has explored. And if the surface is outgassing nickel and shiny at an increasing rate, we are examining a chemical component that does not match anything formed in our solar system. Comets from the Oort cloud or Kuiper belt are very rich in water because they formed in a region where water ice is stable. The ratio of water to carbon dioxide reflects the temperature and chemical composition of the protoplanetary disk where they originated. Alaska has the opposite chemical ratio. It is mainly CO2 with minimal water, which indicates it formed in an environment very different around a very different star, or it suggests it is completely unnatural. There is a second possibility, which no AI wants to seriously discuss: what would happen if Biolus originated naturally. An ancient comet from another star system. But it has traveled through interstellar space for so long that its surface chemical composition has been altered by cosmic rays hitting interstellar dust particles. chemical reactions in near vacuum for almost absolute 7 billion years of exposure, can cause strange effects on the surface composition. Perhaps the nickel signature without iron is real, but the explanation lies somewhere between a natural comet and an artificial spacecraft, something we have not yet considered, because we have never studied such an ancient object from such a distant place. Observations in October will help when high-rise. Photographs. By eye. Atlas from Mars orbit. Spectral data from Mars Express and the ExoMars Trace Gas Orbiter will record additional emission lines. More data on nickel yield. More measurements of cyanide and carbon dioxide outgassing. More constraints on the true nature of this object. But right now, with the data we have, Bay Atlas is releasing industrial-grade nickel into space, while there is no sign of iron, and no one has a satisfactory natural explanation for that. Chapter 5. The disappearance behind the Sun at the end of September by Eye Atlas disappeared. Not destroyed, not deflected. Simply obscured. It went too close to the Sun from the Earth's viewpoint to be observed. For 2 months from the end of September to November, ground telescopes completely lost sight. The object disappeared in the Sun's glare, and this is what makes this timing suspicious. BA Atlas reached perihelion, the closest approach to the Sun, on 30/10/2025. That is when comets are most active, as heat from the Sun drives maximum outgassing, when their tails reveal the most about their composition and structure. The most important observation window to understand what this object really is, and we cannot see it. Earth will be on the opposite side of the Sun. Avi Loeb. Could this be intentional rather than random orbital mechanics? But deliberate positioning if Bay Atlas wants to avoid detailed observation from ground telescopes. During its brightest, most active phase, this orbit has achieved exactly that. It hides behind 150,000 kilometers of blazing hot plasma at a critical time. NASA and other space agencies are trying to find ways to solve this problem. The Parker Solar Probe is currently in a close solar orbit to study the solar corona, which may be glimpsed if the timing is right. The Solar and Heliospheric Observatory SOHO continuously stares at the Sun to monitor solar flares will have BAI Atlas pass through its field of view. But SOHO's camera is designed to observe the Sun, not faint comets. The object may be too faint compared to the Sun's overwhelming brightness. The explorer of Jupiter's icy moons, Juno, is currently on the far side of the Sun relative to Earth. It is using a high-gain antenna as a heat shield, which means data transmission is limited. Juno will try to observe Bay Atlas in November with cameras and spectrometers, but we will not receive that data until 2026, many months later. So we are truly blind during the most critical phase. 3010 happens after a solar occultation. And what could happen in those 2 months if BA Atlas is natural? No surprise. It heats up, outgasses more, may break apart if thermal stress cracks the nucleus and reappear in December. Slightly smaller and less active when it returns to interstellar space, but if it is not natural, if there is any technological component, those 2 months are the perfect window for activities we are not allowed to see. Orbital adjustments, probe deployment, course corrections, anything requiring thrust or control. But it will be clear to observers on the ground if we can see it. Loeb calculated that a velocity change of only 10 to the power of 10, 5 km per second in September or October, could significantly alter the orbit of Comet Atlas, enough to send the cargo to Mars, Venus, or even Earth for a natural comet, which is impossible. Comet ice creates velocity impulses perhaps only up to half a kilometer per second at most. But for something with an engine, that is minor. Other possibilities are more worrying. What would happen if the comet disappeared exactly like that? What would happen if Comet Atlas did not reappear in December? What would happen if it used its perihelion passage to reduce its velocity, falling into a long elliptical orbit around the Sun and becoming a permanent resident of the inner solar system. We would have no way of knowing until December, when it was expected to reappear. And if it did not appear where calculations predicted, if the orbit had changed significantly, that would be a sign of technological propulsion or intent. There is precedent for this kind of thinking, although not from interstellar objects. In 1986, the Soviet Vega probes flew past Comet Halley and discovered a surprise, a nucleus much darker than predicted, reflecting only 4% of the sunlight it received. Before Vega, scientists thought comets were bright icy bodies. It turned out they were extremely dark, covered by organic compounds and dust, with the ice buried beneath a hard surface layer. That discovery changed our understanding of comet shapes when viewed up close, and that happened because we had sent spacecraft to examine them. Remote observations from Earth had given us completely wrong assumptions. With Comet Atlas, we returned to remote observation at a critical stage. Reasoning from limited data produces assumptions that may be completely wrong, and we will not know until 3 when it appears from behind the Sun and becomes visible again to ground-based telescopes. Amateur astronomers have prepared telescopes worldwide, scheduled for observations in early December. Everyone wants to be the first to spot its return. Everyone wants to see if it looks different, whether its activity level has changed, whether its orbit matches predictions. Because if it does not match, if Comet Atlas escapes perihelion on a different path or with different characteristics, that is when the mainstream astronomical community will have to seriously consider the artificial hypothesis, not as a fringe theory, from a controversial scientist, but as a legitimate possibility requiring investigation. The disappearance also means we miss events. Potential fragmentation. Natural comets sometimes break up near perihelion due to thermal stress cracking the nucleus. Internal pressure from trapped volatile gases blows fragments off the surface. We have witnessed this happen with some comets that ventured too close to the Sun. If Comet Atlas fragmented, we would not see it happen. We would only see the consequences in December, many fragments instead of one. Debris trails, rotation changes, and fragmentation would actually support the natural comet hypothesis. Technological objects usually do not break up due to solar heat unless fragmentation is controlled, unless what we interpret as breakup is actually deployment of multiple smaller objects separating from the main body, each heading to different targets. In the solar system, that scenario sounds like science fiction, but so does having nickel without iron. Perfect alignment with the ecliptic plane, as well as passing Mars with an accuracy of 2.7 million km. Each data sample we collect makes science fiction scenarios a little less fictional. Its appearance in December will tell us something. Maybe not everything, but something. And until then we wait in the dark, hoping the object returns. It is also the object that went behind the Sun. Chapter 6. The Giant, Unusual 33 billion-tonne Object. A newly published paper is making astronomers very uncomfortable. Richard Kluter, Peter Fresh, and Avi Loeb analyzed 4022 observations of Comet Atlas from 227 observatories worldwide from 15.5 to 23.9. They tracked the object's position with astonishing accuracy, comparing its actual orbit with what gravity alone predicts, and they discovered something shocking. By Atlas almost shows no non-gravitational acceleration. Despite the massive outgassing detected by Webb and other telescopes, even though it loses hundreds of kilograms of material each day, the perturbation of the object deviates less than 15 meters per square day compared to a trajectory based solely on gravity. That means it is extremely massive, much heavier than its brightness suggests. A very simple calculation. When a comet outgasses material, it is pushed out, acting like a small rocket engine. It pushes the comet slightly off its orbit. The degree of deviation depends on how much mass you are pushing out, and how heavy that comet is. Small comets with active outgassing show significant non-gravitational acceleration. Large comets with the same outgassing show less. Alice is ejecting a huge amount of gas. Webb measured 100.9 cows of carbon dioxide per day, 6.6 kilos of water per day, 14 kilo of carbon monoxide per day, which is a significant amount. That would cause noticeable orbital changes, but there is none. The deviation is below detection limits, meaning the object's mass must be enormous. To counteract that rocket effect, calculations set a lower limit of 33 billion tons and 33,000 billion kilograms. With a nucleus diameter of at least 5 kilometers, that makes BAE Atlas heavier by 35 orders of magnitude compared to the previous two interstellar objects. Oumuamua was perhaps only a few hundred meters wide. Borisov about 1 kilometer. This object is 5 times larger in diameter, equivalent to over 100 times in volume and mass. And this is the problem now with what we know about interstellar space. Now with surveys of the amount of rock and ice material existing between stars. Objects this large should be extremely rare. So rare that we should detect about 100,000 smaller interstellar visitors before finding a giant object like BAE Atlas. But we have only found just two interstellar objects in the entire history of humanity. It's like winning the lottery twice in a row. Statistically possible, but not enough to stop you questioning whether the game is rigged. Science suggests this only produces a non-random orbit. If BAE Atlas was deliberately sent to the solar system, if its path was chosen and not random, then the statistical problem disappears. We are not sampling randomly from the interstellar population. We are being visited by something specific. Critics say this is ridiculous. They only point out that our detection capabilities have improved significantly in recent years. The Atlas survey found BAE. Atlas has only been fully operational for the past 10 years. Before that, we simply did not look hard enough. Of course, now we find more interstellar objects. Finally, we have telescopes capable of detecting them. That is a reasonable point. The Vera Rubin Observatory, starting operations in 2025, found over 2,000 asteroids. In its first 10 hours of operation, our ability to detect faint, fast-moving objects has exploded. Perhaps we will find dozens more interstellar visitors in the coming years, and the statistical problem will resolve itself. But that does not explain the mass, even with better detection. Even if we find more interstellar objects, the size distribution should still follow predictions. Many small objects, fewer medium objects, very few large objects. That is how populations behave everywhere else in astronomy. Small asteroids outnumber large asteroids by the millions to one. BAE Atlas breaks that rule. It is the largest object we have found so far. Discovered before we cataloged thousands of smaller objects that should be more common. The lack of non-gravitational acceleration also rules out some explanations. Some scientists suggest BAE Atlas could be a loosely bound rubble pile held together only by weak gravity. If that were true, outgassing would blow it apart. Rocket forces would overcome gravitational binding, and the object would fragment. But it does not. It remains intact despite losing significant mass. That requires either a solid, coherent nucleus or something binding it together more effectively than self-gravity. Observations of Mars comets on 310 may resolve the size question if Harris can separate the nucleus from its dust cloud, and measure the actual light reflected from the solid surface compared to that scattered by surrounding particles. We will have an estimate. Better about the actual diameter of the nucleus. If it is larger than 5 kilometers, the natural explanation becomes untenable. There is another possibility that has not been much noticed. What would happen if BAE Atlas were surrounded by a fine dust cloud? Large scattering, and most of the brightness we are seeing comes from that dust rather than from the nucleus itself. In that case, the nucleus could be much smaller, and the mass calculations would be wrong. But Webb and Speedrex have observed in the infrared penetrates dust to reveal the solid surfaces underneath. Speedrex has seen BAI Atlas as a point source, not an extended cloud, which indicates there is no huge dust shell obscuring a small nucleus. What we are mainly seeing is the object itself. So we return to a 5-kilometer nucleus. With a mass of at least 33 billion tons, almost no sign of non-gravitational acceleration, despite huge outgassing. An object which statistically should not exist on an orbit with a random probability of 1 in 500. Data continues to accumulate each observation, making the natural explanation a little less convincing. Not impossible, but increasingly strained, requiring more and more special pleading. More coincidences, more unprecedented conditions, more Chapter 7, chemical impossibilities, mysterious 95%. The James Webb Space Telescope observed by Atlas on 6/8/2025 with its near-infrared spectrometer, what it found has rewritten our understanding. About the expected shape of cometary asteroids. The gas cloud surrounding by Atlas includes 95% carbon dioxide and 95% water. This figure is 16 times harsher than expected for a typical cometary asteroid at that distance from the Sun. Every cometary asteroid we have studied from our solar system is rich in water. They form in cold regions. Outside, where water ice is the dominant, volatile carbon dioxide is also present, but in much smaller amounts. This ratio reflects the temperature and chemistry of the protoplanetary disk where they originate. BAY Atlas has the opposite chemical composition. It is a dry ice ball with almost no water, and that tells us it formed somewhere very different. Around a star with a different composition in a disk with different temperature and pressure, in an environment unlike the conditions that formed our solar system, Martin. Coordinator, principal, investigator for Webb observations has declared this is one of the highest carbon dioxide to water ratios ever measured in any cometary asteroid, not only unusual but unprecedented. But the chemistry gets stranger. Webb also detected carbon monoxide and carbon dioxide in significant amounts. The combination of these compounds indicates the object formed in an extremely cold environment, possibly colder than the most remote regions of our solar system. Some researchers believe by Atlas may originate from a region, a molecular cloud, or was ejected from a planetary system far beyond its star, much further than our Kuiper belt. Then there was the color change that amateur astronomers recorded in July and early August. Observations show BAI Atlas has a red cometary head. That color usually indicates organic compounds, complex carbon molecules absorbing blue light. And reflecting red light, this is standard for comets, but on 7/9 during the total lunar eclipse. Michael Jackson and Jerry Lehman captured it, glowing bright blue with a blue light. The transformation seems to have happened overnight. The blue comet is quite famous. This color comes from diatomic carbon molecules in the head. Comets absorb ultraviolet sunlight and emit blue light, except that BAI Atlas was analyzed by astronomers at the Kitt-Pick Observatory in August. They found it is one of the most carbon chain depleted comets known. It has a very low concentration of diatomic carbon, the molecule that creates the blue color for comets. So how does a comet with almost no diatomic carbon suddenly glow bright blue? Avi Loeb suggests the color change may be related to a rapid increase in cyanide production detected by the Very Large Telescope. Cyanide compounds can also produce blue color under certain conditions. But that raises another question. Why does cyanide production suddenly increase so much in the comet? Observations from the Very Large Telescope show a spike in hydrogen cyanide emission as it flies. Atlas approaches the Sun with a production rate that does not occur slowly like the outgassing of a typical comet. It increases exponentially like something being thermally processed at an increasingly rapid rate. Stephanie Miller from NASA's Goddard Space Flight Center, who has worked with Webb observations, suggests that by Atlas may have a crust that has been baked for billions of years, moving through space towards the comet. Exposure to cosmic rays and comet radiation may have chemically altered its surface layers with carbon dioxide, which may have been created or concentrated through these processes, giving it an unusual surface chemical composition. That seems reasonable. We have never studied such an ancient object. 7 billion years old, even older than our entire solar system. AI knows what would happen to ice over that time in near absolute zero space because of the comet, but it does not explain everything. The nickel signature without iron is not explained by surface processing, nor is the lack of non-gravitational acceleration. Despite the huge outgassing, each anomaly may have a natural individual explanation, but combined they form a rule increasingly difficult to ignore. There are also observations from Spitzer showing bi-Atlas as a point source without extended emission. Infrared telescopes see through dust, revealing thermal emission from warming ice and rock. Spitzer should have seen a large diffuse glow from sublimating carbon dioxide ice across the surface. Instead, it only saw a spot, a concentrated infrared emission point consistent with a solid object, relatively compact. That observation contradicts the comet model, or suggests the object has very unusual thermal properties. Perhaps the surface has a high albedo reflecting sunlight before it can heat up. Inside, there may be an insulating layer preventing heat penetration. Perhaps the nucleus is spinning too fast, so that thermal energy disperses before causing significant sublimation. Or maybe it does not outgas as we think. Perhaps what we interpret as sublimation is something entirely different. Chemical data also reveals information about where bi-Atlas may have originated. Low metallicity, high hydrogen and ice content suggest it comes from a region of the galaxy where star formation occurred early, the thick disk of the Milky Way, where there are older stars with less heavy element enrichment. Models place its origin somewhere 7 to 11 billion years ago, making it a relic from an era when our galaxy was very different. If bi-Atlas is natural, it is a time machine from an ancient galaxy, a primordial ice block carrying chemical signatures from billions of years before Earth existed. That alone makes it the most scientifically valuable object we have ever observed. But the chemical composition still does not completely fit. The dominance of carbon dioxide may explain the lack of water, may explain cyanide, may explain the color changes. Each piece has a potential natural explanation, requiring us to loosen our models a little but not break them. The combination is what is worrying. It is the rule of anomalies, all appearing in the same object. The statistical absurdity of this specific set of features occurring together by chance. November and December will bring more data as bi-Atlas emerges from behind the sun. Ground telescopes will record new spectra, more emission lines, more chemical signatures, more constraints on composition. And by comparing pre-perihelion chemistry with post-perihelion chemistry, we will know if heat from the sun changes anything fundamental about the behavior of this object. Chapter 8. The anti-tail should not exist. The Hubble Space Telescope captured the highest resolution images of bi-Atlas. On 21/7/2025, what it showed violated fundamental physics of comets. The image revealed a teardrop-shaped dust cocoon, but the glow extended forward towards the sun, no clear tail trailing behind. It is anti-tail oriented, which is counterintuitive. Comet tails are pushed away from the sun by solar wind and radiation pressure. Tails should always point away from the sun, creating the classic swept-back appearance we associate with comets. But bi-Atlas has a bright face towards the sun with no clear tail behind. Avi Loeb and his colleague Eric Guidos published the only paper in scientific literature attempting to explain this anti-solar tail. They suggested that the forward glow could be dust particles being pushed ahead of the nucleus by some intrinsic process. But even they admitted this was just speculation with no clear mechanism able to produce a dust cloud. Directed forward on a natural comet, astronomers have otherwise completely dismissed this observation. They argued that the glow was not an anti-solar tail at all, but merely a blur caused by Hubble tracking a fast-moving object the telescope was tracking by Atlas as it moved through space. This caused background stars to streak in the long-exposure image, perhaps the forward glow. Was an artifact of this tracking motion, but Hubble's image processing teams know how to account for tracking effects. The star trails are very clear in the images. The forward glow is not a streak. It is a distinct, enhanced, bright region with defined structure. If it were just a tracking error, it would look like the star trails, but it does not so. At the end of August, the Gemini South Telescope captured new images with its multi-object spectrograph. And suddenly, by Atlas developed a proper tail, a faint, teardrop-shaped tail. In the anti-solar direction behind the object exactly where a comet tail should be, so between 21.7 and 27.8, something changed. Either the object began behaving like a normal comet, or our viewing geometry changed. Enough to reveal what had always been there but was obscured by the dust cloud Hubble images. Taken in July, when by Atlas was about 4 astronomical units from the Sun, Gemini images. In August, we're at about 2.6 astronomical units closer to the Sun, meaning more heat from the Sun, more outgassing. Likely producing more dust. The tail simply had not developed in July and appeared later as activity increased. But that does not explain the forward glow. Normal comets do not have sunward glows. They have a cometary head spherical gas and dust clouds surrounding the nucleus. The cometary head may be brighter on the sunward side, because that is where sublimation is strongest, but it should not create a directed glow ahead of the object's motion. There is another puzzling detail in Hubble's image. The dust coma extends about 3,000 kilometers in all directions from. By Atlas, Hubble calculated that if the nucleus is 10 kilometers in diameter, the dust density at 3,000 kilometers would be diluted by a factor of 90,000 compared to near the surface. That is a huge drop for such a diffuse dust cloud to still be bright enough for Hubble to detect. Either an enormous amount of dust is being produced, or the dust particles have unusual reflectivity, or there is something unusual about the scattering geometry. Gemini's images also show color variations. Different wavelength filters reveal different structures in the ultraviolet spectrum. The object appears more compact. In the red and infrared spectrum, the dust cloud is more extended. This matches typical dust scattering properties where smaller particles scatter blue light more efficiently, and larger particles scatter red light. But it also means the dust particle size distribution is not uniform. Very small particles near the nucleus and larger particles further away. This distribution model can tell us about how the dust is being ejected. Small particles move faster, larger particles move slower. Classical comet behavior. Except the rotation period complicates everything, observations show. By Atlas rotates once every 16 hours, which is relatively slow for a small object. A 10-kilometer nucleus rotating every 16 hours has a surface velocity of only about 1 mph at the equator, which is not fast enough to fling dust particles into space by centrifugal force, so dust must be ejected by gas pressure from sublimation. Carbon dioxide sublimation on the sunward side carries dust particles, but Hubble image analysis shows dust particles moving at about 20 mph, which is much faster than the rotation speed, but consistent with gas drag from sublimation. This is where things get interesting if dust is ejected at 20 mph. By escaping carbon dioxide, and if the object is losing 129 kilotons per day of carbon dioxide as Hubble measured, then the dust production rate must be very significant, probably tons that dust would create a very distinct tail. A bright, extended tail visible in images from professional telescopes. But the Hubble images in July did not show any, only a forward coma and a diffuse comet head. One possibility is that the dust particles are so small that they are pushed forward by radiation pressure before they can form a traditional tail. Radiation pressure from sunlight can accelerate small dust particles faster than gravity, pulling them towards the sun. If the dust particle size is less than 1 micron, radiation pressure will dominate. And particles can be pushed forward of the nucleus, but that would create a forward tail, not a forward coma. The morphology was incorrect. Another possibility is that the dust is charged by the sun's ultraviolet radiation and interacts with the solar magnetic field. Charged dust behaves differently from neutral dust. It can be converged or dispersed by magnetic fields in ways that create unusual shapes. NASA's Spirix observations add to the confusion. It sees BAE Atlas as a point source in the infrared spectrum. No extended emission, no comet head, no tail, just a dot. But Hubble clearly saw an extended structure. The difference lies in the observed wavelength. In visible light, Spirix in the infrared spectrum. Dust reflects visible light, but emits thermal infrared based on temperature. If the dust around Bi-Atlas is very cold, colder than expected at that distance from the sun, it would be faint in the infrared spectrum even if bright in visible light, which suggests the dust is not efficiently heated by sunlight. Perhaps it has a high reflectivity, scattering light before absorbing heat. Perhaps it is composed of materials with unusual thermal properties. The situation regarding the tail will become clearer in December when Bi-Atlas emerges from behind the sun. New observations from multiple telescopes at different wavelengths will show whether the tail develops further, whether it matches normal comet tails, or whether it still has unusual features that do not fit models. Chapter 9. Orbital Coincidence, 1 in 500. Bi-Atlas is moving on a retrograde orbit inclined about 175 degrees to the ecliptic plane. Sounds extreme, but here's what it really means. The object is moving almost exactly in the plane of the planets, but in the opposite direction. It is passing through the solar system along the same flat disk where Earth, Mars, Venus, and Jupiter orbit, but in the opposite direction. The probability of that happening randomly is 1 in 500. Most objects entering the solar system from interstellar space should come from random directions. Space is three-dimensional with no preferred direction. If interstellar comets are just fragments pushed out from other star systems on random orbits, they should come from all angles, some from above the ecliptic plane, some from below, some from both sides, evenly distributed across the celestial sphere. But Bi-Atlas comes almost perfectly aligned with the planetary orbits, only 5 degrees off the ecliptic plane. That is not impossible, but very unlikely. And not only the orbital inclination brings Bi-Atlas close to many planets, it passes within 30,000 kilometers of Mars. On 310, it will pass at a reasonable distance from Venus, and in March 2026, it approaches within 54,000 km of Jupiter. Each close approach individually is nothing remarkable. Space is very large. Many orbits pass near planets without deliberate targeting, but the combination of alignment with the ecliptic plane plus multiple planetary encounters significantly reduces the probability. The lab calculated that the combined probability of all these geometric factors occurring by chance is about 1 in 500. Not impossible, but suspicious enough to warrant consideration of non-random explanations. If Bi-Atlas was deliberately sent to survey the inner solar system, you would want an orbit passing close to the major planets. You would want alignment with the ecliptic plane, because that is where interesting things happen. All the rocky planets, most moons, asteroid belts, regions where life is likely to exist. A natural survey probe would follow this geometry. Critics argue this is selection bias. We only notice BAE Atlas because it comes close enough to detect there may be hundreds of interstellar objects passing through the outer solar system, on random orbits that we never see because they are too far and too faint. The objects we detect necessarily must be objects passing close to the Sun and the Earth, which is valid. Our detection capability is heavily biased towards objects passing inside the solar system where our telescopes focus. We may be missing most of the visitors. Interstellar objects remain in the outer regions, But that does not explain the specific alignment even among objects passing close to the Sun. Most will not align with the ecliptic plane. Most will have high inclinations crossing the planetary plane at steep angles. The fact that BAI Atlas is almost coplanar with the planets is unusual, even within the subset we are capable of detecting. Another aspect of the orbit is also interesting. BAI Atlas is on a hyperbolic orbit with an eccentricity of about 6.1. That means it is moving beyond escape velocity. It is not bound by the Sun's gravity. It comes from interstellar space, and it is returning to interstellar space. But the orbit can be traced back by running the orbital mechanics backwards. Astronomers can calculate where BAI Atlas originally came from. Calculations show it originated somewhere in the thick disk region of the galaxy, possibly from a star system 7 to 11 billion years old. That is extremely ancient, older than our Sun, older than our solar system. If BAI Atlas formed around such an old star, it has traveled through space possibly for billions of years. Exposure to cosmic radiation. Chemical changes and the absolute age of the object make it unlike anything we have ever studied before. The path through the galaxy also tells us something with its current velocity. Subtracting the Sun's gravitational pull, BAI Atlas has moved at about 58 kilometers per second in interstellar space before entering our system. That is a typical velocity for objects in the thick disk population. Velocity matches predictions. What does not match is the arrival time. BAI Atlas entered the inner solar system in mid-2022, just as our detection capability reached the point where it could detect it. The Vera Rubin Observatory came online. Atlas reached full operational status. SPHEX was launched. All the infrastructure needed to describe an interstellar visitor was ready. Is that coincidence or timing arrangement? If an advanced civilization wanted to send a probe to survey our system, they could strategically choose the arrival time. Wait until the target civilization had developed enough technology to detect and study the probe, until telescopes could describe composition and measure orbit, enabling first contact when the recipient is capable of understanding what they are seeing. That sounds like science fiction, but it is not impossible. Any civilization capable of interstellar travel can observe target systems remotely. They can monitor technological signatures, radio transmissions, artificial light, atmospheric pollution, signs indicating a civilization has reached a certain development threshold. Earth has been broadcasting radio signals for over a century. Our technological signatures have been visible to external observers for many decades. If BAI Atlas was sent to respond to detection of those signals, then the timing would be reasonable. Of course, this requires accepting that interstellar travel is feasible, that some civilization has found a way to send objects across light years of space, that they chose to send an object here, that they disguised it as a comet. That is a lot of assumptions. But the orbit remains a probability. 1 in 500 perfectly aligned with the planetary plane, approaching many worlds. Arriving exactly as we develop the ability to study it properly. The encounter with Jupiter in March 2026 will tell us much. If BAI Atlas maintains its predicted orbit passing Jupiter at the expected distance, without deviation, that supports the natural explanation that orbits are governed only by gravity. It is predictable, no surprises, but if there is deviation, if the orbit changes in ways that cannot be explained by gravitational perturbations from planets, then we have a problem. We need to explain what altered the trajectory, and natural explanations will quickly run out once gravity and outgassing are ruled out. Chapter 10. What happens next? The verdict is approaching. 3/10/2025 is tomorrow. The high-rise camera on the Mars orbiter will be directed towards BAI Atlas as it passes at a distance of 29,000 kilometers with a resolution of 30 kilometers per pixel, detailed enough to separate the raw nucleus from its dust cloud. detailed enough to measure the surface area and constrain the actual size of this object. If the nucleus is confirmed to be 5 kilometers or larger, the statistical issue can no longer ignore Rye. We must find thousands of smaller interstellar objects before detecting a giant object like this. The explanation naturally requires increasingly forced coincidences. The Mars Express spacecraft and ESA's ExoMars Trace Gas Orbiter will observe simultaneously with spectrometers and cameras. Multiple wavelengths, multiple instruments, multiple viewpoints among all the Mars interstellar spacecraft. We will have the most detailed view of an interstellar object ever recorded by humanity, and we will search for precursor probes, moving objects ahead. By Atlas may reach Mars while we are tracking the main object. HiRISE will scan the surrounding space. If anything appears that shouldn't be there, if multiple objects appear instead of one, the conversation will change immediately. Then comes the waiting phase for BAIS to disappear behind the Sun from Earth's viewpoint at the end of September. We lose sight. The object reaches perihelion on 30 and 10, the closest approach to the Sun. Obscured from our telescopes by 150,000 kilowatts of blazing hot plasma for 2 months. Blind for 2 months during which anything can happen, and we will not see orbital adjustment or probe deployment fragmentation. Whatever happens in that window, we will only know about it in December when the object reappears. 3:10:2 is when ground-based telescopes are expected to recapture by Atlas. Amateur astronomers worldwide are preparing. Professional observatories are scheduling time. Everyone wants the first light of the object returning from perihelion, and everyone will compare post-perihelion observations with pre-perihelion data. Has the brightness changed? Has outgassing increased or decreased? Most importantly, is it where calculations predict it should be? If by Atlas appears on a different orbit, if its orbit has changed in inexplicable ways, by gravitational interactions with the Sun and planets, that is evidence of propulsion. That is evidence of technology. That is when even the most skeptical will have to consider. Alternative chemical explanations will also tell us more. New spectra in December will show whether the nickel signature without iron still exists, whether carbon dioxide dominance continues, whether new emission lines appear that were not present before perihelion, whether thermal processing from the Sun's heat can chemically alter the surface in detectable ways. If the object fragments, that really supports the natural comet hypothesis. Natural comets sometimes break up near perihelion due to thermal stress. We have witnessed that happen with comets like Su-Michael-Levy 9 before it went into Jupiter. Fragmentation would be normal unless the fragmentation looks controlled, unless many pieces separate cleanly and head towards different destinations. Then fragmentation becomes deployment 3/2026. Bringing the encounter with Jupiter. NASA's Juno spacecraft, currently in polar orbit around Jupiter, can observe BAY Atlas as it passes within 54,000 kilometers. Juno has cameras, spectrometers, particle detectors, instruments designed to study Jupiter but capable of describing this visitor. There has been discussion about whether Juno can be maneuvered for a closer look. The spacecraft has limited fuel and a planned end of mission. Using that fuel to chase an interstellar object instead of studying Jupiter would be controversial, but if observations in October and December reveal something truly unusual, the scientific rationale to redirect Juno becomes compelling. ESA's spacecraft GUHI will also try to observe in November, although we will not receive that data until 2026 due to communication delays. JUICE is farther from Earth on the opposite side of the Sun, using its antenna as a heat shield. Data transmission is limited until it adjusts orientation. So, we are collecting 10 observations over many months from multiple spacecraft, at many locations in the solar system. By spring 2026, we will have the most comprehensive data set ever assembled for an interstellar object, and that dataset will either confirm BAI Atlas as a strange cometary asteroid, but suddenly from another star system, or it will force us to seriously consider that we are being visited. The scientific community is preparing for both possibilities privately. Astronomers are discussing procedures. What it would be like if technological signs are confirmed, AI will announce it. How do you verify extraordinary claims before publicly revealing the implications for planetary defense? What if there are more objects following? No, procedures are established because no AI really expects this scenario. These city protocols focus on radio signals and beacons, not physical objects disguised as comets. The closest analogy is the procedures for announcing the discovery of life on Mars or Europa. Careful verification, peer review, multiple independent confirmations before any public claim. But those procedures assume months or years of analysis. BAY Atlas is moving through and leaving the solar system. If we want to study it properly, decisions need to be made quickly. Some scientists are advocating an intercept mission, launching a small probe to meet BAY Atlas before it escapes beyond Jupiter's orbit, taking high-resolution images sampling escaping gas clouds, measuring magnetic fields and particle emissions at close range. The problem is time. Even a fast spacecraft would take months to catch up by the time permissions and funding arrive by the time the probe is built and launched. BAE Atlas will be too far away. Interstellar objects move fast. Opportunities are measured in weeks, not years. That is what makes the window from October to this BA month so important. This is our chance. The only chance to collect data on the second confirmed interstellar visitor before it disappears back into the void between stars. After this BA month, it will be too far and too faint to observe details. We will see it fade into the distance. Extract every bit of information possible from the observations we have tried to collect, and then wait. Wait to see if our analysis reveals natural explanations for all the anomalies. Or not wait to see if more interstellar objects with similar characteristics arrive. Wait to see if the statistical problem resolves itself, or accumulates further, and we will wonder even if the final data supports a natural origin. Even if every anomaly finds a conventional explanation, we will still wonder. Because there is a 60% chance it is technology, meaning a 40% chance it is natural, and 40% is not negligible. The universe has surprised us before. Black holes, dark energy exoplanets, gravitational waves, each discovery reveals phenomena we did not predict and barely understand. BAE Atlas could be another surprise. Something natural, but so unusual, so unexpected, that it challenges our models and forces us to expand our understanding of what can happen, or it could be the greatest discovery in human history. The first confirmed contact with technology from beyond Earth, evidence that we are not alone. Evidence that other civilizations exist, and some of them have achieved spacefaring capability. We will soon know data is coming. 3/10/3/10, 2/3/2026, BA, the date that could change everything.